Java functions provide a means to modularize your code. They are an extension of the object-oriented ideas of encapsulation and polymorphism. If you use functions effectively, they will enable you to reuse your code more and reinvent the wheel less. Both of the aforementioned outcomes are stated objectives for an object-oriented language. To summarize it succinctly, if you use functions effectively, you will get more done in less time. A function's method declaration is comprised of the function's header. This consists of a modifier, which can be public, protected, private, or static, a return type, which is a particular data type, or void if there is no return type, the function's name, which can be anything you want to call it, and parameters that the function takes in parentheses, or if there are no parameters, just empty parentheses. A Java function has two distinct aspects. One, a definition. A definition is a block of code between curly braces to be executed when that function is called. Two, a call or invocation, where a previously defined function is put into action. When we call a function, we say we invoke it. Variables received by a function or in its definition are called parameters. Variables passed into a function when it is being called are known as arguments. Okay, so far I've looked at the way memory works, and variables, primitive data types, decision structures, if and else, and nested if and else, and switch statements, repetition structures such as for loops, while loops, and do while loops. Today we want to take a look at functions. A function is a way to make your code more modular. It's a way to encapsulate things. Now you could write programs or applications and put thousands of lines of code in just one function, and it would work that way, and in some ways it may even be a bit more efficient if there are less stops and starts where one function invokes another, but that's a very poor way to write a program. It makes your code very difficult to manage and maintain. On the other hand, if you break your code up into smaller chunks, functions, and you can logically organize your code, your ideas, your thoughts, your logic, into a more encapsulated form. And not only that, you can reuse your code. If there are things you do repetitively, instead of needlessly reinventing the wheel or retyping things, you can put it into a function, make that function a widget, and every time you need to do that certain task, you simply call that widget forth or invoke it. You can think of functions sort of like a to-do list. If your significant other or your spouse leaves a to-do list for you on the door before you go to work, that list just sits there, and it may say, go to the store and get milk and eggs, and go to the pharmacy and get my prescription filled, and put gas in the car or fill the tires up with air. But although those instructions are there on the list, they don't get executed. They don't actually do anything until you pick up the list and take it with you and begin to implement what's on it. So you can think of functions as being the same. It's a way of creating a to-do list with your code, and you can simply call that to-do list every time you need to perform a certain task or to achieve a certain result. Let's take a look at some of the basic parts of a function. We talked about these briefly in our first example when we were creating our Hello World application in the console, but remember that this is a modifier, the keyword public, and there are three in Java. There's public, private, and protected. Public is the least restrictive modifier, and it gives not only objects built from this class, but also any child objects that inherit from it permission to access data and methods that are declared as public. Now, private, on the other hand, is the most restrictive. And if something is declared as private, it can only be accessed by an object built directly from that class, and it can only be accessed directly in the class. So if data is private, then normally you would practice what's called data hiding, and you would write public accessors and use your public accessors to get at that private data. So public and private are sort of direct opposites, but there's also a third, and that's protected. And protected is sort of intermediate, or between the two. And basically, as protected, an object built from this class could access protected data, but not an inherited object or a child class. So public, private, protected. For most of what we do, will be used in public. Static is another modifier, and as a keyword, it means something that will become clearer as we study classes. But basically, in Java, before you can access a method or a function on something, you have to construct or build an object from that class first. However, there's a problem, at least with the first class that we're running here in the console. And that is, I need to call code that's in main long before I've built the object. In this case, I'm just, I'm saying Java and I'm passing in functions to the virtual machine, so I haven't really had an opportunity to build objects from this class. If I did, then I could just use a dot operator, and I could say, if my functions objects were called ABC, I could say a.main, b.main, c.main. But since this is the only class in our project and the first class, I don't have that option. I don't have that luxury. So I need to make this a static function. There are reasons to make things static. Obviously, if you only have one class, and this is your first class, it should be static. There would be no other way to run that main function. But there are other reasons as well. Let's say I want to have, a piece of data shared among all instances of a class. Normally, every class is going to have its own set of variables, its own set of functions and methods. But if I make them static, they can be shared among all instances of that class. And that could be useful for things like counting objects or optimizing memory. If they don't need to have their own separate set of data, then I can use less memory and make a program's footprint smaller by making more data static. So just an option as far as a modifier. This is a return type. In this case, main doesn't return anything. Now, if a function doesn't return anything, then its return type is void. But optionally, it could return an integer, a double, a string, a character, any valid data type. Or even classes later that we create ourselves. It could return a zombie, or a giant, or a dragon, or an FBI agent. In parentheses here go a function's arguments or parameters. And they are the variables that you would pass in this case a primitive data type. And this is just an array of strings. But these would get passed to the function, and they're treated as local variables inside that function. So we've used main before. We're going to create an empty function, and we will give it no return type, and we'll call it main menu. And if I did this, okay, to start my program, let's look at how functions are invoked and what happens in program flow when they're called. So here I'll simply say welcome to functions 1.0. And let's say that in this function here, I'm going to make myself a menu. And to do that, I'll just want to print, and I can keep using system out print. Oh, don't want to do a pen there. Let me just do print. No one really heard anything, but I'm just going to keep adding strings of text here. And we'll look at a basic menu widget. And this will be a good chance to practice using two of our structures or our tools that we've recently acquired. A repetition structure in the form of a while true loop, and a switch statement, or a decision-making structure. And let's say that for our options here, and I'm just going to we'll add some lines here. And we'll just have Q to quit. Sort of an option there. And we'll add lines. And so that's the menu that I want to display. And what I need to do is I kind of need to keep this whole thing going until I get a valid option. And then in addition to that, I need to make a decision based on it. So, I mean, the first thing we want to do, we've given the user some choices. We need to take some kind of input. So how could we do that? In this case, we'll use a line number reader. And I'm going to import Java IO and add a wildcard there, an asterisk, to grab the whole package. And this will be our main menu function. And I'm going to add a third function in here. And since we're using one class, also I'm going to make all these static. I'm going to add just a third function, a helper function. And this function, as a matter of fact, instead of having no return type, I'm going to return a string. And we'll just call it the input function. Okay, and it doesn't take any arguments, no parameters, but what I want to do is, create for myself or use a line number reader. And actually I could build it in this function, but it would be a bit less efficient to sit there and build a new line number reader. I guess it depends on how you look at it. I may use up a few more CPU cycles if I build it every time I call this. On the other hand, if I make it local to the function, then when this function is done, any variables that are local to a function would be destroyed or cleaned up. So that would give me more memory, but it may cost me a bit more in terms of processing speed or CPU cycles. That's all negligible anyway, because this is a very simple program and we're only in the console. But those are just things you may think about when you're trying to think of how can you optimize your code. So to save memory, I could make it local, and then when input is done, it's destroyed and that memory is available. However, to save processing time, I may choose to build it out here and leave it global, and then that way I don't have to actually sit there and build a line number reader every time I call input. Either way, we'll opt for saving memory here. So when we're not using it, we won't use our line number reader. But the syntax is line number reader equals, let's give it a name here. We'll call it n. And I'm going to put this argument on the next line, but as an argument to the line number reader, what goes into what we call the constructor, you would pass in a new input stream reader. And then as an argument to that, sort of like the scanner object, you would pass in system in. So that'll build us a new line number reader. And then the other thing I want is a temporary string, and this is local again to this function, so when input is done, temp is destroyed, the memory is free or released. Now I could also have a global string out here called temp, and remember when we talked about scope, global and local, even though they would both have the same name, they would be two different variables. They'd have two different memory addresses. One would be global, one would be local. But this needs to be put inside of try and catch blocks. So I'm going to try, and I'm going to catch. And what I want to try is, I want to take in, call a function readLine, and I want to assign the results of that, or the return value of readLine, to my temporary string. And then what I want to catch is an IO exception. And then you can do what you like there. You can say system error print or system out print. Either way, do it a stack trace or just a message. I'll just say IO error there, and I want to kind of try and catch that. And then finally, once I've gotten what I need, I'll just want to return that value. And in this function, I'm telling, my return type is not void, unlike this function up here. So I don't need the keyword return because I'm not returning anything. It's void. Here, however, input's going to return a string, so I need to end the function with the keyword return. And if I specify I'm returning any kind of data, I always have to end with return and a matching data type. So I couldn't return an integer, I couldn't return a double, I've got to return a string. In this case, the string typed in from the console. But the usefulness of this is we just made a widget or a function that will take care of input. So now when I want input, yeah, before I had to do all of this every single time I wanted to get input. Now I can just turn around and invoke or call my function. And this is a to-do list for how to get input from the console using a line number reader, and the virtual machine will just go do that and execute the code and then come back and give me the string or spit out the string that the line number reader picked up. So it's kind of a very convenient thing, and if I do that, then that lets me do this. I need to store the user's choice, so I'm going to come up here and let's go ahead and take their choice, and I'll come down here and I'll get that via input. And so what happens? When I'm in this function main menu, it's going to turn around and call the function input. Input's going to do what it's supposed to do, which is take the line number reader, read a line of text, store it in a string, and return that string, spit it out when it's done, and throw it to whatever's on the left of the assignment operator. In this case, my string choice up here. Oh, and that should be assignment. Let me change that. And just to kind of separate these functions too, I'll throw in some comment tags here and here. So let me just add, I'll go here and I'll go here, and let me go here and here, and alright, so just adding some comment tags. That way you can kind of see we have three functions now: a main function, a main menu, and input. Now we're not done with our menu yet, but we have encapsulated by creating two different functions. So the next thing I need to do is make a decision based on that. And I could have, remember, I can't switch on a whole string. I can only switch on a single character. But the problem is, if I use a single character up here and not a string, and they type more than one character, it will overflow the buffer. Remember, character is only 1 byte, but they could type in a whole word like banana and have 5 or 6 bytes. So this is just a way of bulletproofing that a little bit. But the problem I now have is, okay, now I can handle more than one character if they give me more than one, but how am I going to process that when in my switch I can only process a single character? And the way to do that is I can use a function called char@, and you just access it via the dot operator on any string. So every string has a series of built-in functions. As a matter of fact, if you want to see what they are, just hit the dot operator and look at all of the functions that pop up in NetBeans. And these kind of give you all of the string functions that you can access or scope into. But the particular one we're interested in is char@. And that'll give us, it's indexed from 0, so the first character is actually 0, the second character will be 1, and so forth. So that'll just give me the very first character. And now I can build my cases like we did before. And this is switching on a character, not a number, so my cases need to be in single quotes. And don't forget your break. But the things I'm testing for, yes, they're numbers, but they're not actual integer numbers. These are just ASCII numbers. Remember we talked about how memory works and how every actual integer also has an ASCII character value. So that's just an ASCII character one. But we'll add some cases here, and we'll do one for 1, 2, 3, and then the last one would be quit if they decide to quit. And then of course also we need to handle, crazy input, or what if they give us something that's just meaningless. They type banana or fruit salad. Not going to be very useful to us, so we'll tell them invalid input, and that'll be our default statement. And then in our menu we could simply say we'll say do task 1, and we'll go here, two, 3, and then the case here, this would just be our sentinel value, or could become our sentinel value. So, but we'll get, just to give us a little bit of feedback to see what's going on, we'll add a statement in here. So we'll say we're exiting the main menu. Alright, so here's our code. Let's see if I can drag this over. There you go, now you can see everything. There's our switch statement. So that we've got a basic menu. Now the thing is, we just want to keep this rolling until they give us either a valid input, they choose to quit, you know, but we need some way of getting this to repeat itself until they give us what we're looking for in the menu structure. And so the easiest thing to do with a menu would be the use of a while true loop. So I'm going to start the while up here, and I'm going to come down here, and I'll close the while true loop. So that closes, and this whole bit of code, if I can get it all on one screen, this whole bit of code here is a widget, a menu widget, a basic menu in the console. You could always create menus, and nested menus, and just about any kind of menu in the console using this construction here, a repetition structure like a while true loop. So show what the menu options are with system.print. You need to take input either via JOption pane input dialog or a scanner or line number reader, and then you need to make a decision based on that input. Alright, a switch statement. So looking at this, what variable can we use to figure out whether or not we want to exit the main menu? In this case, what we're looking for is Q, right? If they decide to quit, they're going to enter Q. So that becomes our sentinel value. And so we can plug this into here. And there's a function. In C++, you can say this, evaluates to, but you can't say that in Java. Instead, there's a function that you can call on a string, and it's the equals function. And it takes an object as an argument, and in this case, we want to pass in a string. And the string is, we're just looking for Q. And now I'm saying loop as long as choice is Q, well choice is not Q, so this being a pretest loop, this would never happen. I just want to do one more thing, and that's I want to put the logical not there. Now there are three logical operators. There's not, there's and there's or. But in this case, when you see the exclamation point in front of something, that's saying not. So as long as choice is not equal to Q, we want to keep looping and looping. And there's just one more thing that I would want to do here, and I can do it one of several ways, but I don't want them to necessarily have to worry about whether it's uppercase Q or lowercase q. I mean, the computer can be really picky, but in this case, if they hit capital Q, and I'm only building a case for lowercase q, it's not going to exit. It's not going to be the sentinel value. That's what I'm testing for up here. Now I could add one case for capital Q and one case for lowercase q, but that gets very redundant if you have to add two cases for capital and lowercase for every character you're trying to switch on. So another option is you can take any string and use a function called to lowercase to convert all of its characters to lowercase, or to uppercase and convert them to uppercase. In this case, we're testing for a lowercase q, so we want to lowercase. Now I could do this one of several ways. Since input returns a string when it gets done, you remember down here it's spitting out a string, ultimately, even though that's a function call, it ends up becoming a string. So if I wanted to, I could use the dot operator, and I could call to lowercase and convert that whole string to lowercase right on that function. That's a way to do that in one line of code. But that's sort of nesting. And so if you find that confusing, or you don't like the way that looks, then we can do it on two separate lines or in two separate steps. So I'll invoke or call the function input to get input. I'll return the string. I'll catch it in choice. And now what I can do is I can simply say choice is equal to itself, and convert after I convert everything to lowercase. Okay. So it's just another way of maybe bulletproofing your games, your applications a little bit, or making them easier on the player or the user. So I have my basic widget here, and now to call main menu, remember that a function is a to-do list. It doesn't do anything until we invoke it. So in other words, here input is defined. There's the function signature and its definition, but until I actually invoke it here, it does nothing. Likewise, all of this is the main menu function, and it does nothing. It just sits there inert until I actually invoke it or call it from another function, in this case from main. And to do that, all I need to do is supply the function's name. Now again, I've got to watch. If main menu returned a value, I'd have to catch it with a variable. If main menu accepted arguments or parameters, I'd have to pass those in. But since it takes no arguments or parameters and returns nothing, I need no variables to catch a return value, and I don't need to pass parameters or arguments into it. I can just invoke it or call it. So the way this works is, program flow would, upon saying Java functions, I would run the class, it would automatically call the main function, it would display this, and then it would go invoke main menu. So from here on, program execution would stop or pause, and it would go and start running through all of the code statement by statement in main menu. So it builds a string, starts the while true loop, displays the menu options, and then it gets down to here, and it would pause, and now it's going to invoke or call input. So this won't get executed yet, but it's going to go call input. It jumps down and says, oh, okay, well now what should I do? I'll build a line number reader, I'll build a string, I'll get input from the console, and I'll try and catch it and display IO error if something went wrong. And when I'm all done, I'm going to return a string. I have to match the return value here. And when that's done, it would go back all the way to main menu and say, okay, whatever I got from the console, I'll store it in choice, I'll convert it to lowercase. Now I'm going to switch on it, and based on what they choose, 1, 2, 3, or Q, I'll do something valid, and if they give me something crazy, I'll run default and just say invalid input. So just sort of the basic logic there in our functions. So let's build this and run through it real quick. And let me change I refactored that, so I need to change my project, my main class file here. Okay, so changed the main class file and we're in the default package. And welcome to Functions 1.0. We're in main at this point. Now we jump to main menu. We display the options. Now the cursor is blinking. I'm calling the input function, and it's waiting for the line number reader. Let's see what happens if I type in banana, and that tells us invalid input, so it runs the default statement. Now on the other hand, what if I give it valid options? 1, do task 1. 2, do task 2. 3, do task 3. So it's going to each of those cases. Now what if I give it the sentinel value? Exiting main menu, and it exits the function. So again, this is just sort of a very brief introduction to functions, but by now you should be able to understand the usefulness of making your code modular and of encapsulating your code into small, tight, well-defined functions that are widgets that you can lock together or put together with other functions to do greater things.